For this problem, we are given WT. It's a stochastic process with the expected value of WT equal to 0. And we are given the autocorrelation of W of t, and that's equal to alpha multiplied the min of T1 and T2. We are given y of t, or we define y of t as WT minus WT of t minus 1. And that's given for t is greater or equal to 1 and t is less than 1. So what we're asked is to find the expected value of y of t and the autocorrelation of y of t. So for this, we can pretty easily see that if WT is equal to 0, then we plug this in for y of t. So we get the expected value of WT minus WT minus 1 as given by this as our definition of y of t, and that will come out to be equaling 0. Now for the autocorrelation, we substitute our values for y, and we also substitute WT with our respective T1s and T2s. So we get the expected value of W of T1 minus W of T1 minus 1 times the quantity of W of T2 minus W of T2 minus 1. Now after we multiply that out, we get this. Well, we multiply this out and then we substitute our given autocorrelation here. And we'll get alpha times min, the min of T1 and T2, minus alpha times the min of T1 and T2 minus 1, and alpha minus alpha of min T minus 1 and T2, plus finally alpha times the min of T1 minus 1 and T2 minus 2. So given for T2 is less than T1 and T2 is less than T2 minus 1, you can see this graphically here. So once we substitute all of these values in, and pull alpha out, so we get alpha times the quantity of T2 minus T2 plus 1 minus T2 plus T2 minus 1. So as you can see, all those cancel out and we get an answer of 0. So if we switch it around and say T2 is less than T1, but T2 is greater than T1 minus 1, we plug that all in and we get alpha times T2 minus T2 plus 1 minus T1 plus 1 plus T2 minus 1. So after we rearrange a couple things, we get alpha of 1 minus the quantity of T1 minus T2. And that's it. So basically the autocorrelation for T1 minus 2, the absolute value of T1 minus 2 is greater than 1, is equal to 0. And for the absolute value of T1 minus T2 is less than or equal to 1, it's equal to alpha times the quantity of 1 minus the quantity of T1 minus T2. From this, we see that y of t is wide-sense stationary.